All right, in this video, we'll be covering the second part of 8-3 about inverse trigonometric ratios, and then 8-4, which is about angles of depression and angles of elevation. So we worked on 8-3 about if you know the angle to find another side length. But what if you know the side lengths and you want to find the angle? That's how we use inverse trigonometric ratios. Now, back in the day, BC, before calculators, when we had tables, we could look up in the table the ratio and find the angle that matched that closely matches that ratio. But today we don't really have trig tables to go with, so there has to be a way we can use the calculator to find those angles. And the answer is inverse trig ratios have these sine to the -1, tangent to the -1, and cosine to the -1. On our graphing calculator, it's second tan, second cos, and second sine will give you those ratios. Okay, so if you do inverse sine of the sine ratio, it'll give you the angle that would give you that ratio. Or the inverse tangent of a ratio, it'll give you the angle that would give you that ratio. Okay, so if you grab your calculator, again, make sure that you are in degrees and not in radians. Inverse sine of 0.8030 is an angle, I'll just round to 2 decimal places, 53.42 degrees. Okay, on the calculator, inverse tan of 0.1495 is 8.50 degrees. And the inverse cosine of 0.5158 is 58.95 degrees. Okay, hopefully you're getting those same numbers as me. Okay, so find all the missing angles. The figures are not drawn to scale. Now, one thing that's not put in here is that these two angles are different, and this is a right angle. Okay, so I can either begin, now I know that B is 90 degrees. That's pretty simple. But finding the other two, I can either start with A or C. I'll just start with A. Now, from A, I know the hypotenuse and I know the adjacent. So, all right, so katoa. The ratio that relates the adjacent and the hypotenuse would be the cosine ratio. Okay, so I know the cosine ratio is 8/10. So to find the measure of angle A, I will look at the inverse cosine of 8/10. Okay, I know the cosine ratio is 8/10, so what angle would give me that ratio? Okay, I grab my calculator. The inverse cosine of 8/10 is 36.87 degrees. Okay, so angle A must be 36.87 degrees. Okay, now I know that the angles in a triangle add up to be 180, so I take 180 minus 90 minus 36.87, and I find angle C to be 53.13 degrees. Okay, another example. Again, these are not the same, and this is a right angle. Again, I'll just use angle A. Now, this time, so katoa. I know the opposite and the adjacent. So the opposite and the adjacent ratio give me the tangent would be that ratio. Okay, so A, the measure of angle A, is equal to the inverse tangent of the opposite over the adjacent. Okay, so the inverse tangent of opposite over the adjacent, or 3/9, is the measure of angle A would be 18.43 degrees. Okay, and if I take that and add it to 90, and take 180 minus that, I will get 71.57 degrees. Okay, one last example. Again, I'll look at angle A, and again, these angles are not the same, and this is a right angle. So katoa. the measure of angle A equals. Okay, so angle A, I know the opposite and the hypotenuse. And the ratio that relates hypotenuses and opposites is the sine ratio. So the measure of angle A is the inverse sine of 11 over 12. The inverse sine of 11 over 12. And I get 66.44 degrees. So angle A must be 66.44 degrees. And I add that to 90 and subtract that sum from 180, I get 23.56 degrees.